Right, logarithms. This is probably something new to a lot of you, and really all they are they are the inverses to the exponentials that we have already looked at. So let's do some graphing here and kind of get a visual for what they are. F of x is the 2 to the x. We want to graph that and then graph its inverse. So I use some negative and positive x's here. Negative exponent, right, 2 to the negative 1 is going to be 1 over 2 to the first, or 1/2. Something to the 0 power is going to be 1, and so on. So I get my exponential graphed here. It passes the horizontal line test, so yes, its inverse is going to be a function again. How do I get that inverse? Well, if I don't have a rule for it, I just swap out all the x's and y's. So not negative 1 and 1/2, but 1/2 negative 1. Not 0, 1, but 1, 0, and so on. We go ahead and graph all of those, and we get this increasing function. We notice that if I put the line y equals x in here, this diagonal, I could fold and I'd have matching pictures. They'd line up with one another. That's what I would expect with inverse functions. Okay, so what does the inverse do? The original function says I'll give you an exponent and you tell me what the answer is if the base is 2. The inverse then says I'm going to give you what the answer is and you need to tell me what exponent I should put on that 2. That's a lot to write, so we came up with new notation and we said if you're looking for an exponent needed on a base of 2, you're looking for a log base 2 of whatever it is. Let me show you how that's used. All right. The log base b of x equals y, read log base b of x equals y, means y, this answer over here, is the exponent I would put on the base of b to get this value x. Okay? The answer to the log is an exponent. All right, so here's the relationship. If I have log base b of x equals y, that's equivalent to saying the base down here, the subscript, raised to the y, the answer over here, is equal to the x, the thing inside the log. All right, and it kind of makes this little loop. So it's saying log base 2 of 4 should be 2 because if I take this base of 2, raise it to the second power, I will get 4. All right, let me show you another one. If I have log base 2 of 1, that equals 0. Why? Because if I take the base of 2 and I raise it to the 0 power, I get 1. Let's practice going back and forth here. Here's our general formula relationship, and you really need to memorize this. You need to know this conversion here. So if I have 4 to the x is equal to w, well, the 4 is the base, so that's going to be the subscript on my log. The x is the exponent, so that's going to be the answer to my log, and the w is what's going to go inside. It's kind of the, by default, what's left over. So check it out here. Base 4 raised over here to the x equals w. Yes, that would give me back the original. What about this one? Well, our base is p, so that's the subscript on my log. The 2 is the exponent, so that goes on the other side of the equals, so it's got to be log base p of s equals 2. This direction for most folks is a little bit harder than the other way, but just for practice, how would I do? Log base 3 of t equals u. It'd be 3 raised to the u equals t. Log base m of w equals 4. That would be m raised to the 4 equals the w.